Excuse me?
Is this the webinar that Dr. Edward Swartz?
Yeah, we're starting now. Hopefully people will start to join momentarily.
Can they see us?
I'd have to turn this thing around.
What about that thing?
That doesn't, I mean, it works, but then I couldn't do it. I can't do a screen share from there. I just have to turn the podium around. All right, well, we'll see if it will do. Oh, actually Wednesday is, but of course we're not going to be here on Wednesday. But the whole week is National Geography Awareness Week. So now we're recording again. So welcome, Dr. Sikowski, and hopefully eventually a lot of other people to GIS Day at Tennessee State University. And so I'm going to start off with a presentation that will just give the students and others some background on what's happening today. Whoops, I needed to share my screen. And I'm going to share. And now I'm going to open up the presentation. Okay, yeah, Dr. C, can you see the screen? Is the screen share working okay?
Yeah, can you hear me?
Yeah, I can hear you.
Okay, yeah, I can see it fine.
You never know with these things. Okay, so welcome to GIS Day and 2019 at Tennessee State University. This is something that we do every year. And this year, our class went outside and collected atmosphere and surface temperature data. And today, we will convert those data into ArcGIS Online format. And so this is part of our pre-service teacher professional development strategy here at Tennessee State. And of course, again, Dr. Kevin Sikowski is the principal investigator on the Globe Mission Earth grant, which is a close to $8 million project that has several partners that you can see them: University of Toledo, West Ed, Tennessee State University is a partner, UC Berkeley, and so on and so forth. Our primary mission at Tennessee State University is to improve science education for K through 12 pre-service teachers. And so in my role as a Globe trainer since 2001, I certify pre-service and in-service teachers in the Globe protocols. I don't think we have any pre-service teachers here in class yet today. Hopefully they will show up. What's going on today? Maybe people thought it was, anyway, I'm not even going to go there. Okay, so again, this is the TSU Globe partnership. Again, as I mentioned, our primary goal is to increase pre-service teachers in Globe specifically and in science education in general. And so at the end of this class, some of our pre-service teachers will be certified in the Globe atmosphere protocols. And so here are some of the protocols that the pre-service teachers will be certified in: air temperature, surface temperature, and clouds. And so if you students remember, we went outside and collected these data about a few weeks ago. So what we're going to do today is we're going to do a modified Globe atmosphere and surface temperature protocol exercise, and we're going to convert the data that we collected outside in the ArcGIS online format. On the, I guess, left side of the screen, as you can see, is the globe data visualization map. So globe schools all over the world are able to collect and convert their data into map format on the globe website. But as you can see, the data visualization on the globe site is limited to regional, national, and global scale data analysis. But what if we wanted to drill down to, say, our school campus? Well, we wouldn't be able to do that with the ArcGIS Online, we wouldn't be able to do that with the globe visualization. So I've created an add-on which is encouraged by the globe team. And so teachers are encouraged to create add-ons. So this is an add-on using geographic information systems, but will allow students to look at variations in surface and atmospheric temperature within a small area. And you can really see how land surfaces have a significant impact upon those temperatures. So we went out, we collected data using, again, a modified globe atmosphere surface temperature data collection sheet that we'll see in a few moments. And then, well, this is what happened prior to what we're doing now. Prior to this, the TSU class went outside and collected the data. What you're seeing on the screen now is what we would typically do is all of our students would go to a local high school and work with a 9th grade class, engaging in the same data collection exercise that the students participated in on campus in what we call a near-peer learning activity. So we weren't able to align this class or any of my classes with Rodney Donaldson's class at Stratford STEM Magnet High School this year. So we're going to do this live broadcast, and presumably they'll see the recording. We'll definitely be at Stratford for the spring semester. So this is what we're going to attempt to replicate today, an urban heat islands map where we're showing surface temperatures overlaid with a layer of current temperatures, and then we're going to presumably see two different surfaces, and we'll see a variation in temperature, as you can see in this visual here at Stratford High School earlier this year on Earth Day. And as a matter of fact, we had two groups of Stratford students. Notice one group was in the shade, the other group was in the sun, and you can clearly see the increased surface temperature and current temperature in the sun versus the shade, where we have obviously a much lower surface temperature than in the sun, even though these two groups of students were relatively close to one another, maybe not even 30 meters apart, and yet within 30 meters you see a significant variation in temperature based upon surface type and, of course, whether they're in the sun or the shade. And so again, using ArcGIS Online, we can replicate the data. So this is a screenshot from the live Zoom meeting that we did this spring with my students and Rodney Donaldson students, so that we walked them through this process, meaning we walked the 9th graders through this process, through this live interactive activity, and it turned out to be really, really great. But again, this year we couldn't align his class time with our class times, but fortunately, K through 12 schools have the same class throughout the year, so we'll definitely see Mr. Donaldson's class in the spring. But for this class, we're going to presumably do a live, not mean to do that. Okay, let me get out of this some kind of a way. Let's see, do I want to do that? Okay, I made a little mistake there. It's actually started the recording in YouTube. Let me get out of YouTube. All right. Okay, that was close. Did not mean to do that. So again, just for our usual recording purposes. This project is funded by NASA via the Globe Mission Earth Project. Dr. Kevin Sikowski is the PI. And there's the information for those of you who are watching from other places. Okay, so I'm going to end this show now, and still doing the, still got the screen share going. I'm going to go into the next portion of our demo. Okay, so we still only have one laptop. Okay, it's like it's going to be one band, one team, one sound today. All right, so JL, log into the class. We'll get to this part. Can you get into GIS assignment 3?
Yeah, I already downloaded.
Okay, so so what we're going to do is we're going to walk through this exercise. So okay, number 1, and number 2. Yeah, JL, were you able to get the Zoom meeting pulled up? Well, don't worry about that right now. We'll get into that later. But so I guess everybody in the class is going to work in one group, so you all can just hang in, go to JL. I'm glad he brought his laptop, or else we'd be up a creek without a paddle today. I guess people thought today was a holiday for TSU, but yes, I don't know.
Yeah.
Any excuse will do, you know. I'm sure I'll hear what happened was stories later. Okay, so yeah, JL, let me know when you have this assignment pulled up. So the 5 of you are all going to be working together today. And just let me know when you get to this assignment.
Okay.
Okay. So, okay. So first of all, so JL, do you already have an ArcGIS online account?
Sir.
Okay. So don't open it yet. Just want to, so we don't, so the first part of this, for those of you who are watching in the audience, the first part, the students would sign up for their own ArcGIS online public account. So those are the instructions. But since the students have already have an account, we will skip past that, and we'll get right into the building the attribute table for the ArcGIS Online program. Okay, so JL, if you are in the, so what you have to do is, well, I guess we'll just download all the data, group 1, group 2, and the data and the spreadsheet. So you'll download the attribute table sheet here. And then save that somewhere. So what this is a modified, well, it's not, to Excel spreadsheet that we're going to convert into a attribute data table for ArcGIS Online. Create a new folder here. We can call this GIS Day, so everything is in one place. So save the attribute table, and also get the data from group 1 and group 2. So here's the group 2. So I took the data that you all collected outside and I scanned it into 2 different files by your groups. And the plan was to work in groups today, but obviously, you know, sometimes plans don't go as planned. What did I just do? Okay. All right. So that's that. And now I'm going to go back into, it's so hard to maneuver. Okay, so I'm going to get, that was group 2. Now I'm going to get group 1's data. Okay, so were you able to do that, JL?
Yes.
Okay, so let me see if I can make this. Are you able to get the Zoom meeting? We have to install first. Yeah, do the install first. Okay, well, for now, just, well, for the rest of you all, if you have your mobile devices, you can actually download, you can actually participate on your phone with the Zoom app. So if you download the Zoom app, Zoom meeting application. So why don't you all who are on your mobile devices do that, and the rest. Let me see. Yeah, I don't know. That should be it. And then, anyway, let me know when you all get logged in. So in the meantime, so we'll let JL be the lead as far as data. So as you can see, what we have here is Group 1's data sheet. So JL, you'll need to have that open first, and also at the same time. So what we're going to do is we're going to transfer the globe data from the globe, modified globe data collection sheets and to onto the into the attribute table. So here we have the attribute table, and then we have the so let's start off with the so we have so this yes. Oh yeah, just yeah. Let the other ones do that for right now. But I mean, if you're there, yeah, just the meeting ID is right on the top. I guess since we're here, I mean, yeah. So yeah, the meeting. See the meeting ID 362-548-2653. It's right at the top of the screen.
Oh.
Yeah. So if you join this meeting, I should start this. Oh, here come. There's JL. So, okay, so if JL you all can kind of position yourself, you can adjust your camera, then we can see the class, or you can join on your own phone. There we go. So now we have our students. You can see our students. Yes, they're here today, well, some of them. And, oh, there's Keeks. Okay, she's in. Now you're there, you can see yourself there. So this is, so now we have, I thought there would be like literally hundreds of people in here. There's Dr. Chakowski, it's one person. It's early. You kind of mute your, can I mute? Yeah, just mute. Then we won't get the feedback. Okay, so now we have a group here, so we can see the students. And so, okay, so let's start off. So here we have the attribute table. And now normally we would have observer names individually here, but obviously that's not going to be the case today. So JL, do you have the spreadsheet open?
Yeah, I'm trying to get out of the screen.
Oh. Are you at full screen with Zoom?
Yeah, I'm in full screen with Zoom.
Yeah, you can minimize the. Where is it? Exit full screen. You see view options.
Yeah.
Oh, you're there. Okay, so. Oh. Someone else is echoing. Okay. All right, no more echo. Okay, so for observer names, so just for today's purposes, we're just gonna just make JL the observer. So since he's piloting us. Okay, so the data that we're about to add to the sheet is group 1. So we'll put group 1 first. And okay, so now we're gonna go to our data collection sheet. See, so the date was, what was the date? Oh, so long ago. So the date was October 23rd. So under date and 23, 2019. And then the time. So are you able to follow me, JL?
Yeah.
Now I thought we recorded the time in here somewhere. I think we recorded the time on the investigation sheet. I thought we did. Maybe we didn't record the time. Oh, yes, we did. The time was about 10:38 a.m. So now normally we would do that in Greenwich Mean Time, but we're not going to do that. Oh, Hobart has a laptop too. Hobart was in group 2. So let's see. So Earl and who else is in Hobart's group? That's here. The Earl and Calhoun, you can kind of migrate and get Hobart up to speed since she's in your group. All right. So, so here's what we're going to do. Since I'm working with group 1's data, so the rest of you all are in group 1. So what I'm going to do is we're going to walk through group 1's data first, which is not going to take very long. And then once Hobart gets, then we'll go back and get Hobart's group 2 established, and then we'll walk through, we'll get the data for group 2 up. And we have plenty of time. We still have another hour, and so we're good. So the time was what, 10:38 a.m. So now we go back to the data collection sheet. Obviously, so here's the data collection sheet. I'm going through this kind of fast. So we get the school name from here. So basically what we're doing is we're just taking data from the site definition sheets and converting it into the attribute table. So there's a TSU main campus. So just type in TSU main campus. So now we have 2 study sites, and so the data is from the Old Courtyard Lawn Northwest. So this is the Old Courtyard Lawn Northwest. Okay, now study site location. So if you remember, we didn't do this when we were outside, but I'm just going to do it now. But normally when we're outside, this is something I might have to add to the comments. What we usually do in terms of data collection with GPS is we would normally say here for the site definition, or would not normally, what I probably should have added is a general location. And so remember, we locate sites based upon distance and direction from some fixed point. And that is just in case one of us, we write in these numbers, you can transpose the numbers. Sometimes you forget to put the minus sign in front of longitude, and you wind up with a point that is not where it's supposed to be. And so as a check, we put in an approximate location so that when we drop these points on the ArcGIS online map, we know where the point should be. If it doesn't wind up there, then we know something went wrong, somebody transposed a number, and so on and so forth. So I just happen to know, remember, that this study site location is, let's just say approx 50 meters east of Boswell Hall sign. So that's where this point should be. I just happen to know that, but that's where it should be. We didn't do that. We were outside. Probably should have, but that's part of the learning process. Okay, so JL, how are we doing? Are you walk? Okay, so now we need latitude and longitude, and so we'll go back to our site definition sheet. So you notice this is why a teammate makes the dream work. This is exactly why we work in groups. This is what we call a teachable moment. So notice I can kind of read this latitude. I definitely can't read that longitude, but fortunately we work in groups. Let's see what the next group person wrote. Let's see, site definition. Okay, this is Robinson. So he's an engineering major. And so engineering majors have to write very neatly. So this is like 36.16518 for latitude. 36.16518 latitude, and then longitude is negative, remember, negative 86 in the Western Hemisphere, negative 86.83083. 83083. Okay, so next we are going to add the current temperature data, which we got from our data collection sheet. And so we modified the surface temperature data sheet to include current temperature. Notice that's in degrees Celsius. Okay, so, well, okay, I know what we're gonna do in a minute. So the current temperature from the liquid filled thermometer, and we have to include that, is, of course, was 23 degrees Celsius. So notice I did not add the C there, and that is because we can't mix text and digits or text and numbers in a number cell. So we don't have to put the C there. We know that all data that's collected in Globe is collected in metric units or degrees Celsius. Okay, now we did, I don't know if we collected, I don't know, we didn't do the Kestrel data, so we're not going to fill in that blank. You can just put an NA there. Don't put a slash in there. Who knows? No characters. Just NA is fine. Now the globe surface temperature with the infrared thermometer. So maybe someone else in group one can help out here, because you notice that I did not have the infrared thermometer set to collect data in Celsius degrees. But I did that on purpose so that you will have to convert. Now, what we would normally do if you were working with students is these students would perhaps be 9 different students, and each individual student would have the responsibility of converting his or her Fahrenheit data into degrees Celsius. It's a little bit of, and they would normally do it using math form, using the actual formula. But today, what I will allow you to do is to average, so someone else besides JL can do this, is to average the 9 Fahrenheit measurements and then convert that into degrees Celsius and then tell me what that is. Okay, Holbert. So while you all are doing that, I'm going to go back to group group two. And so are Holbert and Earl, you all here? Have you downloaded the information? Oh, yeah, don't worry about Zoom right now. Don't worry about Zoom right now. Just get to the course website, GIS assignment 3. Oh, you download the file? Okay, so do you have this open?
Yeah.
And did you download your data?
Yeah.
Okay, let me get the group 2 data. Let me just
Give me the decimal points.
get me in a little bit of trouble. Okay, so then we have Holbert sheet. Okay, so let's see. So okay, so you all notice that. Okay, so since group 2 is actually here,
69.
we'll actually put the people's names. Here's what I'm going to do. I'm going to put the initials of the people who are actually here. So we have for group 1, who's here? We have Lane. What's your first name, Lane? That's JL. So we have JL. Let's do J Lane. Might be able to spit it out. And who else is here?
So 72 is what?
No, wait a minute, Ming, aren't you in group 1? Wait, this is group. Yeah, you are in group 1. I'm sorry. So we have Lane. Ming, what's your first name, Ming? Yeah, Ming. And Manley, what's your first name, Manley? Okay, so, all right. And I don't think Dale's the pilot, so we know who he is. And so from group 2, we have, so what you all, okay, we'll do this later. So group 2, what we're going to do is we're going to fill in your data on the second line, and then you're going to copy the data from group 1. Okay, so for now we have Earl. Your first name is Earl, and K Holbert, and I think that's. Then you have group 2 here. Yeah, so you're group 2. And the date's going to be this, I think, wait a minute, we have to go back. And, well, it's the same date. We know it was the same date. Oh. Who was that? See, it wasn't, it's not Otero or, it's Calhoun. And I don't know what her first name is. We'll wait till she comes back. Or I'll look on her sheet. Okay, so now group 2, let's see if we got the time here. I think we wrote the time down. Almost sure we did. I hope we did. Because it might have been, if we didn't, we'll just have to make a note. We have to be more careful next time that we record the time. I don't think, I don't know how, oh, there it is. So this is, oh, Calhoun recorded the time. It's same time, okay. That's why teamwork makes the dream work. That work in teams, somebody's gonna collect the data. School name is the same, TSU main campus. Now your study site name, if you notice, is Old Courtyard Northwest Corner. So you all weren't on the lawn, so your is Old Courtyard, not Lawn Northwest, Old Courtyard Northwest Corner. And so, are you all following me? Are you getting this into your spreadsheet? Okay. Am I going too fast? Group 1. Oh, no, you guys are group 2. I'm sorry, that's group 2. Okay. So let me know. So how are we doing with the math over here? Calculating the, you can convert the surface temperature into degrees Celsius. Well, what's that number?
That was 23.6.
23.6. Okay. That's interesting. All right. Okay, so all right. So I'm gonna get group 2 caught up, and then Calhoun, what's your first name? Oh, I just need the K. All right. So now we have all the 2 people here today. Oops. Okay, so so I'm going to get 2 caught up so that we will both be at the same place with the assignment. So group 2, group 2, you are at study site location. I'm gonna have to give that to you. So Calhoun, are you at study site location on the spreadsheet? Yes. Okay, so so for study site location, this site was approximately 50 meters east, not a different location, 50 meters east of northeast corner of Boswell. So it's 50 meters, approximately 50 meters east. It's like I said, we were just, normally we would have a tape measure but we didn't, we were out there, we had limited time that day within an 85-minute class period like this one is. But we still have plenty of time. We still have 45 minutes to get this done. We will get it done. And we will not let our viewing audience down. Okay, so now group 2 is at latitude and longitude. So you go to your site definition sheet. And let's see here. Okay, so we got Wayne's. So the latitude is 36.16518. Wait a minute. Wait. Wait. I can't. Right. Maybe I'm on the wrong sheet. Yeah, this is Holbert. Okay. So luckily, again, teamwork makes the dream work. Well, we'll find out in a minute which one of these is correct. But obviously, as you can see, they're different. So let's go with Holbert's 36.16578. 36.16578. So let's just do a quick check. Okay, so we know that the Boswell, we know that group 2 point is a little bit farther north than group 1's point, right? So notice that our latitude is slightly higher for group 2. So we know that is probably correct, and I don't want to break down how much farther north, but we know that apparently one of the people in the group made a mistake. It happens, but luckily that's why we have 5 people working in each group, and at least one person got it right, and so luckily Holbert. Got it right. So let's look at longitude. Remember, it's minus 86.83096. 83. Okay. And again, okay, so now we're both approximately at the same place. So for group 2, your current temperature, so we have to go down into the data. I mean, yeah, I'm working with group 2, yeah, right now. So group 2, yeah, I'm gonna get them caught up. So for group 2, the current temperature you all recorded was 22 degrees Celsius. So that was the temperature you got with the liquid filled thermometer. Again, just the number, no C. We all know that the data is in degrees Celsius. And again, so now put an NA in the cell for Kestrel. We did not have the Kestrel meters out. Actually, JL had the Kestrel meter out there, but we didn't record the data for this particular exercise. It was for a separate. Okay, now globe surface temperature with the infrared thermometer. So now group 2, they have to do the same thing that group 1 did. So what you're going to do is take the average, the Fahrenheit temperatures, and then convert that into degrees Celsius, and then let me know when you have that number. Yes, that'll work just fine. Like I said, normally a globe teacher would have 9 different students, or you could even have however many students, right? Even though technically you're only supposed to get 9 points, but if you wanted to modify this, have each student in your class take a measurement using the infrared thermometer, and then each student would individually go through, do the math, and convert the degrees Fahrenheit into degrees Celsius. Of course, today I'm going to let you all use other means to make that conversion, but normally if we're working with 3rd graders or 5th graders or whatever grade, we would have them do that calculation by hand. Yes. Oh, group 1. Oh yeah, they're in the sheet. Now I'm only recording the members of the group 1 that are here today. People wander in later. Oh, you mean group 1? Oh, that group. You're group 2. Oh, sorry. A little bit of my angst is coming out at our low attendance today. Yeah, so, okay. So I guess you all good. You're multitasking. So do we have a surface temperature, IRT surface temperature for group 2 yet? Oh, still calculating? Okay, so Calhoun, you still need to see this sheet, right, for group. So Calhoun is getting the group 1 information. Oops. Okay, so can't tell. Normally I can tell how many people are logged in. Oh. So are there any questions from our viewing audience while we
What's the land cover?
Oh yeah, we're gonna get I meant from people out there viewing, all these hundreds of people. Let me see if I can. Oh, Dr. Archer. See, Dr. Reginald Archer has joined us. You know, I guess it's a holiday. A lot of people aren't at work today, so they're like, I'm not logging in, nothing. But okay, that's fine. That's fine. We're recording it, and that's fine. So Calhoun, how are you doing? You got this latitude, longitude. You get the liquid thermometer temperature. Okay, NA, and then you got their RT temperature. Okay, so group 2, what is your infrared thermometer temperature? Okay. All right. So we're just gonna wait for them to. So in the meantime, so for the viewing audience, Okay. Is that it? Is it 27.2? Is that what we're gonna go with?
That's what I can
Okay.
calculate it.
For their data. Okay. So is that let's check our data here. That sounds about right to me. Given what we're about to do in the next couple of steps, perhaps. So group 2 is so yeah, so Holbert, yeah, why don't you show what your group is doing?
Well, we were just kind of getting.
No, I mean I wanted to put you on the screen. So you have your phone there. Oh, you got it on. Okay. Oh, there you go. See, now we can see your whole group. So there they are. Group 2 is working on the calculation for land. Excuse me. For the we're just double checking the. They got 27.5. Well, since that's their data, we'll go with their numbers. We have another teachable moment. We're not going to go into that teachable moment right now. We don't have time. Okay, we're getting there. We're close. We're very close. We're definitely going to get this done unless there's. I'm not going to jinx myself. Okay, so now next, everybody's caught up. Now we have land cover. So land cover is going to be on the site definition sheet. So this is, I don't know, that student knows what's going on there. So land cover for group 2 for surface temperature is, I think it's concrete. Is that correct? Yes, so group 2 was Old Courtyard, northwest corner. Yes, so your land cover was concrete. And so we'll put concrete there. And so for group, I'm sorry, concrete. Okay, so for group 1, what was your land cover? Wait. And this is, you have to get it from the surface temperature. Yeah, so not the site definition. Yeah, since we're doing surface temperature specifically, then.
Yeah, short grass.
Okay, so short grass, okay. Short grass. And so next, what was the cloud cover percent that day? I think, wasn't it like 0? 0. And so cloud type, then we didn't see any cloud. There was not a cloud in the sky that day, which was kind of a bummer, but we can't control that yet. Okay, so now we have completed the attribute data table. So now we have to go to, file, save as, let's call this globe atmosphere investigation surface temperature map attribute table. Let's just change this to, let's save it as 1, okay? So that way we're differentiating the attribute table from the blank tables. And then we're going to save that, okay? We're going to save it in Excel first, okay? So you hope we're able to save the table. Group 2, we're able to save this table. Oh, we okay? At some point, yeah, we're not, maybe not now. At some point, we're going to do a switch and we're going to do a screen share from one of you all. So do you have this table saved? Okay, good. Okay, now carefully just put, highlight one, at least one cell in the spreadsheet. Just highlight one cell in the spreadsheet. Then go to File, Save As. Yeah, somebody's not muted. That's fine. It's not a big echo. Go to File, Save As, and then under File, Save As Type, select CSV. CSV. So is everybody here? Yeah, comma delimited format, because that's the format that ArcGIS Online can read. Yeah, it should be a CSV comma delimited. You got the JL? Okay, now to go here, boom, and hit save. Now what's going to happen is you're going to get all kinds of strange error messages. Just hit okay, yes. Then you have to close this file because it can't run in Arc and Excel at the same time. So when you close it, it's going to give you, just hit save, just keep it yes, yes. Yeah, so don't worry about all those error messages. What you essentially did was you converted a multi-sheet Excel spreadsheet into a single sheet CSV file. Okay, so now we are almost to the promised land. Well, wait a minute. Ooh, man. Okay, very quickly. Does one of you have an ArcGIS Online account? Okay, yeah, log into your account, Earl. Yeah, just open up a different window. So, JL, you already have your account? So go to your ArcGIS Online account. So we're going to log into ArcGIS Online. And let me know when you all are here. I might switch up and do a screen share from one of you. Yeah, it probably should be what we do. And I'll try to walk you through it. Because yeah, there's not much to walk through. I don't know. We'll see what happens. We'll see what happens. Yeah, I'll try to walk it. Well, we'll see. I don't know. This is all live. See how many people we have tuned in. And there's probably so many people. Oh wow, man! I guess it's a holiday. Maybe tomorrow we'll have more people. But I guess everybody's off from work and doing what they do on holiday, not tuning in to see us. Okay. So are you there yet? You here?
Yes.
Okay, so do you see, okay, I'm gonna hit stop share on my computer. Okay, so I've stopped sharing. So JL, what I want you to do, what's all this in the chat box? Question Jet, there's some echoes. Oh, he's a PI on this whole project. How many students are missing? Oh, we won't answer that. So JL, do you see on the bottom of your screen where it says share screen? Go back to yeah. It hits share. Okay, and you got your screen to share again? Right there. Okay, now everybody should see. Okay, good. Okay, so now this is JL's screen. So I'm gonna. But you are you logged into your?
Yeah, I'm logging in the connection.
Okay, so we're gonna. We'll walk through with JL. Although we should let somebody else in the group do this, but that's fine. JL's. Okay, everybody, teamwork makes Okay, so JL, I want you to go up here to go to the add button. Add your add layer from file. Choose file, navigate to your spreadsheet. Yeah, you just find it wherever it is. You just okay, that's it. That's the CSV file. Okay, open it, import layer. Just hit OK. It should be fine. Yeah, just click OK. Don't worry about that error message. Okay. Oh, okay. See where it says choose attribute to show? Change that from cloud type to current temperature liquid. Okay, wait a second. Okay, hit done. Just hit done. Okay, pull out, zoom out a little bit. Maybe we're zoomed in too far. Oh, okay, there we go. Okay, so now click on legend, go to legend. Yeah, see in the upper right, right there. Okay, so if you notice, we have the, well, we notice a couple of things here. Oh, change the base map. Go to base map, change the base map to imagery. Change it to image, just imagery, not the hybrid yet. Let me see if that holds up. Change the base map to imagery hybrid. That looks like a new, I haven't seen that base map before. It looks like a new one. Let's see, maybe we have, it's pretty much the same thing. Oh, no, it isn't. Oh, it has labels. Okay, yeah, it used to be imagery with labels. I didn't know that. Imagery hybrid. It's like, what's that? Okay, so first, well, here's, well, this is what we call a teachable moment. Whoa. So zoom back in again. Zoom back in, and it's okay, things happen. Okay, so I want you to take the cursor and click on that smaller dot. I mean, not, you don't have to zoom in that far. Yeah, zoom out a little bit. Yeah, because we want to be able to see the other, the buildings. Okay, click on that dot. Okay, so this is group 2. So notice that if you look at our, this is exactly why we do this. Notice that it says that the study site location should be approximately 50 meters east of Boswell, of northeast corner of Boswell. Zoom out a little bit more. And so you can click out of the, close the dialog box. Yeah, just hit the X up in the upper right-hand corner. Yeah. Okay, so now if you notice where Boswell Hall is, right? Point to Boswell Hall. You see it? It's a bit near to the go here. There's Boswell. So that point was supposed to be 50 meters east of Boswell. Clearly, it is not. So apparently, there's some kind of an error that we're going to correct the error, and I'll show you how to do that. But now notice if you click on the second, the larger circle, notice that we're about 50 meters east of Boswell Hall. Sign, that point isn't exactly where it should be either, if you remember. So, okay, here's what we're going to do. So obviously, and this might not be your fault. Remember, the GPS receivers, sometimes they do not get the exact location. If somebody might have transposed some numbers. Who knows what happened out there? But luckily, we have a backup then we know now that these data are incorrect. So here's what we're going to do. But anyway, before we do that, let's just work with what we have now and click on Add Data again. And search Layer from File. And then choose File. Bring the CSV file in again. I mean, the locations are off, but we can still work with the data. So bring that in again, open it, import layer. Just click OK. Now change the attribute to show to globe surface IRT. Give it a second. Okay, okay, so go to, options. Click on symbols. Okay, click on fill. Okay, change the color to, let's see, this is IRT, change it to red, change the fill to red. Change the print transparency to 50%. Or maybe greater, maybe about 75%. Maybe, yeah, about right there. And then hit OK. Okay, hit OK again. Yeah, there. And then hit done. Let's see what we get. Hit done. Okay, go to legend. Okay, so now we have two separate layers. We have the, well, it's not what we want, but I mean, it is what it is. So, okay, so just hold right there. So if you notice, if you look at the point to the north, notice that in that case, the surface temperature is significantly higher than the current, well, it's a few degrees higher than the current temperature. What it is that the relative sizes of the differences in temperature are exaggerated somewhat. That's all that's happening there. So just click on the point to the north. Yeah, just click there. It's fine. And so notice that scroll down to see what the surface should have been. Scroll down that table. Yeah, see the arrow? You can just pull it, just drag it down. Oh, it's freezing? Oh, okay. When it unfreezes. Okay, so group one, where are you all? Yeah, Earl, where are you all? Oh, group two, I'm sorry, group two.
We're just following along.
Okay, I mean, so have you saved the CSV file? Are you, whoa, what, wait. Yeah, JL, you took the screen share off? Oh. Yeah, just go back to your screen share. And okay, you're back. Okay, so group two, have you been able to bring your points into the map yet?
Yeah.
Okay, so just give me 1 second. Yeah, okay, so notice the land, so right there, land cover is concrete, just freeze it right there. So land cover is concrete and cloud cover is % is 0. So we would assume it was a bright sunny day, nope, not a cloud in the sky. It was 10:38 in the morning. So we'd assume at that time of day, full not a cloud in the sky. We're getting the full brunt of the sun on this concrete. And notice that the surface temperature, scroll up just a little bit, JL, right there. Notice that the surface temperature on that concrete in the sun is elevated above the current temperature, which is 23 Celsius. Close the dialog box. You can clearly see that the symbology does reflect exactly what the data show. So in terms of GIS, and what you're looking at, we look at a geographic information systems map, is not actually a map, it's actually data. And so you see how important it is to have accurate data when we produce these maps. So by building the attribute data table, you're able to do that. Oh, so very important. So JL, hit that button that says save. And then go to save as, and then give the map, you know, maybe a name that you can remember, group 1, GI, whatever, globe mapping, blah, blah, blah. And then you can add a tag, might be Tennessee State University, or a tag might be GIS Day. A good tag would be GIS Day. Another good tag would be Globe Program. Okay, so I'm going to go over. So we've had success. Just had a slight error with our GIS or GPS. Okay, so JL, take your screen share off. Yeah, stop share. Okay, Ashley, go to your screen share. I want you to share your screen. Yeah, you see where it says, okay. Okay, so, all right, well, we have the same data, so we have the same issues. What is all this pink? Okay, never mind. I mean, that's your computer. Okay, I thought there was something going on. Okay, so let's see. So this is this is on my screen. Okay. Okay. So you've added. Oh, so you've got both layer. Oh, okay. So you're all completely caught up. Good. Did you save it yet?
Yes.
Okay. So go down to the southernmost point, and okay. So notice that. Scroll down. So notice that in this case, we are on. Scroll down. Yeah, so notice that in this case, sunny day, short grass instead of concrete, but there's only a 0.6 of a degree difference in the temperature between the surface and the ambient temperature. So this clearly shows, if we want to talk about the urban heat island effect with this image, even though that the concrete clearly increases surface temperatures. Now, obviously, the symbology is somewhat exaggerated. We would probably, if we had time, go in and try to adjust the sizes of our volumetric symbols so that we wouldn't have the exaggeration. But having the exaggeration, and this is kind of a brief lesson in cartography, having the exaggeration in our symbols does really emphasize, of course, in an exaggerated fashion, the urban heat island effect per se, with that concrete surface clearly having a greater effect upon the surface temperature or ambient temperature actually than the grass under the same conditions on the same day. And so we have, you know, cloudless day. And so could you close the dialog box, please? Let's just use some more. Yes, yeah. Oh, there you go. Okay, so move your screen up. Pull the, just slightly. Okay, right there. Okay, so here's something else we can do. So Earl, click on the measure tool. And click on, so see where that little ruler is? Click on that, yes. And then instead of, well, we're gonna use, well, click on that, yeah. Do meters, since we are supposedly doing globe now. Okay, now, close that. Let's see if this, click on the, one of the dots, just right in the center. Just click, oh, no, okay, go back, wait a minute. So do this, drag the screen to the left a little bit. Okay, keep going left. Okay, right there. Now go to the measure symbol. This thing's getting in the way of each other. Go there, meters. Okay, now keep that open. Now click on one of the dots. Just click once. Okay, now drag to the other dot. Just drag it. Yep, just like that. Boom. Okay, now so we're about only 67 meters apart. These 2 points on the same day are only a few 67 meters apart, and yet you can see the temperature differential even within this small area. So in terms of what we're trying to do with Globe is that using ArcGIS Online as a data visualization, we can look at temperature differentiations even within a school campus or within a very small area, which cannot be done with the globe visualization as is, unless you had 2 globe schools that were right next to one another. Okay, so we still have some time left. So let's try to fix this problem. Let's try. Okay, well, since we have Earl up, and you, group 1 can follow along. Okay, here's what we're gonna do. Excuse me?
Should we say who we have?
Yeah, you can say you can just click out of that and just keep clicking. You can just close the box and say, but just don't stop the screen share. We're gonna still roll with group. You can, oh. Okay, so Earl, so go to, well, both groups. Go to, no, go to Google. Go to Google Maps. Go to Google Maps. Okay, and let's see where we wind up here. Google Maps. So we've had a relatively successful venture here today. Let's see. Okay, so well, it's going slowly. So what we're going to do is in the next maybe 8 minutes is correct these errors. I don't know what happened out there. We were in a real hurry that day, so maybe some numbers got transposed. At least we didn't have a point show up in Williamson County somewhere, which happens from time to time. Okay, zoom right in on Tennessee State University's camp. Oh, it's still cranking along. Okay, come on now. I mean, it could be because, well, anyway, it is what it is.
Zoom all the way in.
Yeah, just zoom into TSU's campus. Okay. Is your Google Maps up, Ballard?
Yes.
Okay, now here we go. Keep zooming. Let's see, where is that? Where are we? Oh, move over to closer to Crouch. we'll move over closer to the old courtyard. Okay, yeah, yeah, you're getting close. Okay, that's crouch. See that little dot? That's where we are. Okay, change it to the satellite view. That'll make it easier.
I can do that.
Yeah, click on satellite, okay. And eventually it's gonna show up. Man, what is going on here? All right. Still loading. Hit the refresh. All right, come on now. So for our viewing audience, welcome again. Oh, so Dr. Chakowski is saying it might be the fact that we're all on Zoom. All right. Okay. Yeah, it could be a combination of a lot of things. All right. See, we can get 6 minutes, 6 minutes. All right, so here we go. So let's see. Now we know where we were supposed, so group 2, you all had the concrete. So you know where we were supposed to be, right? We were exactly right there. So if you just click on that, drop a pin right there. Whoa, wait, what? Yeah, drop a pin where we were supposed to be. Remember the points that we have on our ArcGIS map are wrong. Oh, yeah, you just click right, yeah, just right there, just click right there, boom, just click, there you go. And, let me move this out of the way. So now you have the lat long, so just write that number down, that 36 point, okay, and we're able to do that. So you know that JL, that here's that light pole, and so here's the Boswell sign. So you know that our second point is about right there. So there's a light pole. So you wish a little bit. There's the Boswell sign. Then it'll be exact. 36. So yeah. So let me see. So let me write it down. I'll write it down too. Let me see. Whoa. Okay. So group 2. What was your lat long? The new lat long?
36.165229.
And longitude?
Negative 86.830920.
Okay, so what you have to do is you have to go back into your Excel spreadsheet and correct that date. You know, just not the CSV. Go back into don't do it there. Go to the Excel spreadsheet because you'll have to correct your raw data. So for group 1, what's your new lat long?
36.16.4931.
Okay.
Negative 86.830697.
Okay. So
you said corrected, not in the CSV.
Yeah, in the Excel, and this is so then when you save it as CSV, of course, when you save this one, change. Remember, the first one was 1. Make this one 2, and then save it, and then convert it. Oh, then there's one more thing you have to do. One more thing. It's very, very important. That I have to tell you to do. later. Okay, the last thing that you'll need to do is when you go into the, well, I'll just, when you, well, okay, it's 2 minutes, still 2 minutes. Yeah, don't worry about doing this right now, okay? Go back to ArcGIS Online, it's much more important. Okay, go to, let me move this out of the way, this is me. Go to share. Click, see that box that says everyone? Fill that in. Scroll down. Scroll down. Hit done. Okay. And then go to share. And then either, well, yeah, not either. Paste that link into the Dropbox comments. And then hit submit, or you can put some notes in there. What do you say? Group 2, yeah, that's fine. I'll group 2. So you got that, JL?
Yes.
And hit submit, and then yeah, try that again. Well, just yeah, go in and just yeah, go in and yeah, submit the spreadsheet, submit something. You can submit the spreadsheet, or yeah, the spreadsheet would be fine. As a matter of fact, that's what you should submit. Yeah, your spreadsheet, the raw spreadsheet, something, and add it, and then hit. I know who was here, so hit add, and you should be good to go. And then I have the corrected parameters. So it's 11 o'clock, so this class is dismissed. So I'm going to halt this part of the program. Well, I'm going to stop recording. I'm going to pause the recording. I'm going to stop the recording. Thanks for joining us. Thanks to the students who came today. We did a really good job today. And enjoy the rest of GIS, Geography Awareness Week.